The multiplication rule for probability tells us that if there are two events, E and F, which are the first and second stages of an experiment, then the probability of E and F is the probability of E times the probability of F with a vertical bar E. What this notation tells us, or how we read that, is that that's the probability of F given E. So assuming that E occurs and then F occurs, we have to look at that conditional probability. And we'll see how we do that, primarily using tree diagrams. In example 9, if you draw from a standard deck, what's the probability of drawing two hearts if selection occurs with replacement? With replacement meaning we draw a card, then we put it back in the deck. For our first outcome, we either draw a heart, or as just a shortcut, I'm just going to say something that's not a heart, so that's all the other three suits. Then on our second draw, we either get a heart again, or we don't get a heart. Or in the case where we didn't draw a heart the first time, on our second draw, we draw a heart, or we don't. This tree diagram is mapping out all of the different possible scenarios. Now we want to add on the probabilities of those different events. The probability of drawing a heart is 13 out of 52. The probability of not drawing a heart is 39 out of 52, so all of the remaining cards. On our second pull, the probability of drawing a heart is still 13 out of 52 because selection is occurring with replacement. That first card went back in the deck. And this probability is still 39 out of 52, 13 out of 52, 39 out of 52. Since selection is occurring with replacement, the probabilities don't change from event to event. Now we need to look at which of these paths is a success. There's only one case where we draw two hearts, the case where we draw a heart on the first hand and draw a heart on the second hand. So our probability is going to be 13 out of 52 times 13 out of 52, or approximately 0.0625. In example 10, we have the exact same scenario occurring, except that I have a typo there. Except now what's happening is that selections are occurring without replacement. This means our tree diagram is going to look identical to start. And our two initial probabilities will be exactly the same. But now we have selection occurring without replacement. So after we draw the first card, we only have 51 cards remaining in the deck to choose from. And if we're looking at a case where we pulled a heart the first time and a heart the second time, there's now one less heart to choose from. So this brings that probability down to 12 out of 51. The probability of not drawing a heart is still 39 possibilities, but also out of just 51 cards remaining, since we've already removed one from the deck. If our first draw is not a heart, there are 13 hearts remaining out of 51 cards, and there are only 38 non-hearts remaining out of those 51 cards. We still only have one option that we would consider a success. That's where we pull a heart and then pull a heart on the second hand as well. In this case, though, that first probability is 13 out of 52 times now just 12 out of 51, since we've reduced the number of hearts and the total number of cards we're drawing from. which gives us a probability of 0.0588.